Let's get started with week 2's probability. We're talking about probability representations. And the first representation we're going to look at is the tree diagram. Now, you've all heard the words before. You've seen it before. Here's a scenario that we're going to look at, okay? It's important to understand what the scenario is before we even look at the tree diagram. So the scenario says, an experiment is planned where a coin is flipped 3 times, and the outcomes, heads or tails, are recorded. Draw a tree diagram to show all possible outcomes. Now, why do we do this? Why do we give this a question in the exam, or why do we need to teach this? Because for probability, it's very important to know what all the possible outcomes are. When you see the formula, you need all possible outcomes in the bottom of your fraction. Okay, so we need to have an idea of all the different possibilities, what they are, so what the possible outcomes are, and also how many there are. So what they are and how many there are. So a tree diagram, helps us with this. When you see the tree diagram results, you'll see all the possibilities, what they are and how many there are, and then we can do any probability question from there. Okay, so it's very useful to draw a tree diagram. They'd often ask you to draw one, or they'll give you one and ask you questions on a tree diagram. Okay, so here is the scenario. Now, when you first see it, you might think, what is going on? If Chiamo was here, we'd see emojis, all right? What is going on? So let me walk you through this. We're flipping a coin 3 times. There's the first flip, the second flip, and the third flip of the coin. Every time we flip the coin, there are 2 possibilities. I'll say that again. Every time we flip the coin, there are 2 possibilities. Okay. And you can see here, the first flip is shown as 2 lines or 2 branches of the tree. Okay. The 2 possibilities here are when you flip a coin are either heads or tails. All right. So that's the first coin flip. Okay. Which makes absolute sense. It should make sense to you. For what happens from here can be a little bit confusing. So what I'm going to do is follow one of the branches of the tree. So we are going to go down this heads branch of the tree. So we're saying here, when we flip the coin first and look at the results, it could be heads. That's a possibility. Now, we flip the coin once, we see heads. We're going to flip the coin a second time. And when you flip that coin a second time, now we're looking over here. All right. The second flip. When we flip the coin the second time, there are, for when we have a heads for the first coin, we could also get a heads for the second coin. All right. Or we could get tails, but there's 2 possibilities. So we could get heads for the first one and also heads for the second one. We could get tails for the second one as well. That's a possibility, but I'm following one of the branches here. All right. So we get heads for the first coin flip. Flip the coin again, we look at it, heads again, and then we're going to flip the coin a third time, which is now this part of the tree. That's the third coin flip, okay? And when we flip the coin the third time, I'll go through it one more time. We flip it at first, we get heads, we flip it again, we see heads again. Now we're going to flip the coin a third time, and again, we have 2 possibilities, and one of them could be heads. Yes, one of them could also be tails, but I'm just looking at one of the branches here. So one of the possibilities when you flip a coin 3 times is to see heads, then heads again, and then heads again, which is this branch that I've drawn here. That's one of the possibilities when you flip a coin 3 times. Heads, heads, and heads. All right. Now there are many other possibilities, many other branches. I'll follow another branch. I'm going to use blue this time. When you flip a coin the first time, you could get tails. Flip it the second time, you could get heads. Flip it a third time, you could get tails. So this branch shows that when we flip the coin 3 times, we got tails the first time, heads the second time, and tails the third time. All right, that's one of the branches of this tree diagram. One of the possibilities. Okay, so we can follow the branches to determine a possibility when flipping the coin 3 times. Now, just seeing this tree diagram isn't enough. There's a lot more to it, all right? We could actually write the numerical probability of getting heads. We could put a half here to say if you get it, you got 1 out of 2 or 50% chance of getting heads, and you also got a 50% chance, 1 out of 2, of getting tails. We're not going to write fractions all over the place yet. Okay, we just want to understand a tree diagram. All right, not only could we write the numerical probabilities on each of these branches, but the more important thing is what's happening at the end, because this is an experiment and we want to show all the possible results. Okay, so what we do and what you should do when you draw a tree diagram is to write out all the possible results in brackets. So for the first branch, this branch, we saw we got heads, then heads, then heads again. All right, so that branch I've written out there, HHH, heads, 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 for that one. You should do the same for all the other branches, all the possible results. That one is heads, heads, tails. The third one is heads, heads, tails, heads. They might ask you to do this in the exam. Heads, tails, tails. Now, those are the first 4 possibilities. Now we're going to the bottom. So this is tails, heads, heads, tails, heads, tails. Let's try to do that a bit neater. Sure, my handwriting's bad. And then tails, tails, heads. And finally, tails, tails, tails. Okay, so when you draw a tree diagram, you need to complete it by writing out in brackets here notation for all the different possibilities. Okay, so if we took the tree diagram away, just for a second, all right, these results here are from our experiments. And without the tree diagram, we could tell what happened. So if I look at the first results, the first result said when you tossed a coin 3 times and recorded the results, you got a heads, and a tails. This one says you got tails first, then you got heads and heads. And this one says you got tails first, then another tails, and then you got heads. All right. So looking at these results, we are able to see all the possible outcomes of our tree diagram. You should do that. If they ask you to draw a tree diagram, it's not just the tree and the branches. These bracketed results and notation are also needed. Okay. Now, this is the cool thing. Once we have all our results, we can answer any probability question. Okay. They're probably going to ask you for the first question when they give you a diagram like this, how many possible outcomes are there if you flip a coin 3 times? How many possible combinations are there if you flip a coin 3 times? And it's easy to see with all these results here. We can see there's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible outcomes. Okay, now that number is very important because that's always going to be in our probability formula when we are answering questions on this diagram. So let me give you an example question. You're going to do one of these as well, but let me give you an example. What is the probability as a fraction that you will get a heads first on your first coin toss when you toss a coin 3 times? What's the probability that you will get heads first if you toss a coin 3 times? Who can tell me? What's the probability as a fraction if you toss a coin 3 times and you record all the results that you will get head first? Very good. Emmanuel. Yes. All right, Emmanuel, check your screen there. Evening, Emmanuel. How are you? Manuel, you there?
Might have
Oh.
been a mistake.
Yeah, Manuel's usually pretty good with answering. I think maybe something's happened there. All right, Emmanuel, we'll try. Can you hear us? We'll try a bit later. It's Emmanuel. Yeah, it's breaking up. The connection's not very good. I think the internet connection is failing you a little bit there. Right, don't stress. It might come right. It might come right a bit later. All right. Yes, so we've got fractions on the screen here. So how do we ask everyone getting a half? Well, for one thing, they can see that there are 8 and there's 4 out of 8. So the probability of getting heads first, and I'm going to write it like this, of getting heads H first, all right, equals how many observed times did we? Yeah, Manuel, still breaking up a bit there, Manuel. All right, yeah, I think Manuel, we're gonna mute you for now, and then we'll come back to you when I think the internet connection is a little bit better. All right, just hold on a sec there, Manuel. So we can see that getting heads first are all these ones here. All right, so there's 4 of them. Okay, so if you want to, you can put ticks. You can say it's this one, this one, this one, and this one. So when you go to your formula, you say there are 4 that have heads first out of a possible total of 8, and that, yes, simplifies to 1/2. Okay, so we can see here that you can ask any question on a tree diagram, and all the possible outcomes are written out for you. It's easy to see them. So when they give you a question like this, where there's heads first, you can see straight away, these are the ones here that have heads first. How many are there? 1, 2, 3, 4 out of a possible of 8. So tree diagrams are actually very useful in seeing all your outcomes. Okay. If you didn't have all these outcomes and you didn't have a tree diagram, it might be a little bit more difficult. With the coin toss, you could think of it. But when it gets more complicated, tree diagrams really, really, really do help. All right. Okay, I'm going to leave that up there. Now, you guys need to get ready. Okay, let's just address this quickly. So someone put in, there are 2 outcomes when you toss a coin. Yes, heads or tails. All right. But if I say heads first, it means the H must be in the front. Okay, let me rephrase the question, and then you guys will see how this works. Let's rephrase the question. Let's remove that. What if I rephrase the question? I said, what is the possibility of getting heads last? What's the possibility or the probability of getting heads last? Now, you guys know what you get when you toss a coin in the beginning, but we don't really know about the end. Well, with the tree diagram and the answers here, we can see 1, 2, 3, 4. There are 4 times that we saw H last. Yes. Okay, so that's 4 out of the 8. All right. Here's another question. Someone needs to help me with this one. What's the probability of getting heads twice in any order? All right. Getting heads twice in any order. Who can help me with this? Would someone like to help me with this? Emmanuel, I don't know if your internet's working a little bit better. Who would like to help me with this?
Somebody.
Anybody.
Anybody.
Somebody.
I'm sure the regulars missed that little song.
Yeah, they did. They did. Anybody out there that wants to help me with this one? What's the probability of getting heads twice in any order? We got answers coming up on the screen, and they're a little bit different. We're getting different answers here. Who's brave enough wants to walk us through? Oh, let me remove the number there. Who's brave enough to walk us through? We're getting different answers. I love it. Anybody out there? Bianca? Anybody? Naledi? Anybody? Olebecheng? Sakile? Sakile is pretty good. Sakile? You out there? Oh,
We have Oliver King and
Olebecheng.
Bianca.
All right, there
Let's
we
take
go.
Oliver King first, and then
All
we'll
right.
move on to Bianca.
Olebecheng, how are you?
Good, thanks, and you?
Good, thank you. Walk us through this. How do we work this out?
Okay, so I looked at the first one, like you said, two in random order, right?
Yes, in any order.
Yes. So like it's the first one, the second one, and then the what's it? Oh yeah, then the third one,
Good.
and then the sixth one, which makes yeah,
Fifth one. That's the fifth one.
yeah,
All right.
yes,
Very good.
which
Now,
makes
yeah.
four.
Okay. Yeah. Here's a question for you. Don't go away.
Yeah.
Now they have to be very specific with the way they pose the question because it can get very confusing. So if in this question you're in the brackets, I say H twice in any order. Some people would argue with you and say your first option, the first one, H, 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 is not twice, that's 3 times. But now I know what you're thinking. I'm thinking, no, but I know what you're thinking. You're probably
Yeah.
thinking twice or more.
Mm.
Yes. Are you thinking twice or more? So
Yes.
at least twice or more, or at least twice. That's what you're thinking, eh?
Yes.
Yeah. All right. So if they said heads twice or more, or at least twice in any order, your first one would be correct. Now they, like I said, they have to pose their question very carefully. So if we say twice or more, or at least twice, yes, 4 out of the 8. If they say only twice, but in any order, then would you say we have to take the first one away? Only
Yes.
twice. Yeah. Then we would take the first one away. All right. So they have to be very careful in how they put the question to you. But yes, I know what you're thinking. At least twice or more. Yes. Good job.
Thank you.
Thank you, young man. All right. So if they're saying just twice, there are 3 times that we see the H twice. In this one, I'll color it. There's an H and an H. In this one here, there's an H and an H. And down here, there's an H and an H. I said in any order. It doesn't have to be the first and the second, or the second and the third, in any order. Okay. All right. Yes, good job. So we could see here that there are 3 that have H twice in any order. If they say at least twice, which means twice or more, then yes, you include the top one because that's got 2 plus another one, which is 3. At least it's got 2. All right. So they've got to pose the question to you very carefully. Now, if you didn't have the tree diagram and these answers here, this kind of question would be a little bit more challenging. You have to agree with me. So the tree diagram and these results shown here are actually very, very, very useful. All right. Now, seeing the answers and doing probability questions on this with the answers in front of you is easy. Thinking how to draw the tree diagram is the challenging part. So here's your scenario. You're going to do this one. Now, I can't see the diagrams you have in front of you. Okay. So I have to trust you. When we finish and I draw it on the screen, you just compare what I have with what you have. But here's the scenario. A husband and wife is planning to have a family of 3 children. Draw a tree diagram to show all the possible outcomes when they have this family. So now let's think about it. They have the first child. What are the possibilities? What could it be? We're talking about boys and girls now. Then they have the second child. Again, what are the possibilities? And then they have the third child. What are the possibilities? All right. So I'm going to let you guys draw that. I'm going to give you 2 minutes to draw a tree diagram. You can use B for boy and G for girl. Instead of H for heads and T for tails, use B for boy and G for girl. I want you to draw a tree diagram to represent the scenario. 3 kids in the family. What will that look like? You guys try it, and then we'll draw it on the screen and you can compare. All right, you guys try to draw the diagram. And then we're going to compare. Don't worry if you're not too sure. Put something down on the page as to what you think it should look like. All right. If you're thinking, I don't even know where to start, just start somewhere. It doesn't have to be right. Does not have to be right. We need to see what your thought process is and we can work with that. But a blank page, we can't really work with that. Okay. So just try something. And then when you see what I have on the screen, if it's a little bit different, you should be asking yourself, why? Why is mine different to that one? And if you see why, then you're learning. That's called learning. All right. So it's okay to make mistakes. It's okay to have a different answer. The most important thing is why. What's the difference? Why is mine different? Okay. So don't be afraid to try. Sinako, how's your diagram going? Sinako Yankees, how you doing? How's your diagram going? You quickly turn the camera off. I can see lots of people are trying. They're thinking very hard. Where do I even start? Sonke, how's your diagram going? Is it all right? Sonke's in his blazer. He's fresh from school or sports, and he's come back to learn. That's fantastic. Ah, there it is. Kia.
I see we have a new Tiamo. Busisiwe is Tiamo incarnated.
Yeah. Busisiwe is a follower of Tiamo. All right, you should have something on your pages there. I'll give you 1 more minute. It can be confusing. It is confusing the first time, but you got to try something. Okay. Yeah, it is confusing. It is confusing. Not knowing where to start. That's the hard part. Not knowing where to start. When you finish it and you look at it, and it'll make sense. But where do you start? Well, think about this. You're going to have one child. All right, the first child. What are the possibilities? You can only have a girl or a boy. That's fine, Bianca. You can have a girl or a boy. Those are the two possibilities. So those are the first branches of your tree. The hard part about a tree diagram is how to space it. You'll find that you run out of space and things get squashed up. Sakile, it does look a lot like the heads and tails diagram because just like heads or tails, there's two options every time you do it. When you have a child, you only have two options of what that child could be, boy or girl. Excellent. All right, let's have a look. Okay, you'll get used to doing these the more you practice. Spacing is important. All right, so I'm going to start off with the first child. Okay, thank you, Emmanuel. Good job. First child. When you have a child, this family has their first child, there are only two possibilities, a boy or a girl. Two possibilities for the first child. I'm going to say B for boy and G for girl. All right, this is the first child. I'll write there, first child. Now, we're going to go to the boy branch of this first option here. You can have a boy for your first child. Then when you have the second child after that boy, again, you have two possibilities after you have your first child. You have a boy or a girl. Right, let's go down to the girl branch. If you have a girl first, and then you have a second child, again, there are two possibilities for the second child, a boy or a girl. This is the second child. All right, now we're going to do the third child. So we've got to go to each branch now. We're going to go to the first one, which is the second child is a boy. Once your second child is a boy, again, you have another child. You could have a boy or a girl. The spacing gets a bit difficult now. Or the second branch of the boy, which is a girl, you can have again, the third child could be a boy or a girl. So on each branch here of the second child, we have to do the third child, which could be a boy or a girl. Boy or a girl. This is the third child. Okay, so you should have something like that. You should have 3 columns, all right? It's difficult to learn how to space it out. You get used to it the more you try. Okay, it's fine. It doesn't matter which one you start with. You can start with the boys or the girls, because girls will start with girls, but boys will start with boys. Doesn't matter. But you should end up with all these possibilities. Now, the next thing to do is to write the notation, okay? Because that's what we're going to work with. So I'm going to put a bracket for the first one. What happened here? There was a boy first, then another boy, and then a girl. Then there was a boy, whoopsie, sorry, girl. The first one was boy, boy, boy. This branch, boy, girl, boy. Fourth branch, boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. Girl, whoopsie. Girl, girl, girl. All right. How am I getting these letters? I'll show you. I'm following the branches. So for example, I'm going to go to this branch, girl, then boy, then girl. So, and this branch here in this line, we should have GBG, girl, boy, girl. All right. So that's how I get these letters. Okay. All right. You should have something like that. If it's a little bit different, check why. And then the next time you do it, I promise you it'll be a little bit easier. Okay. Now that we have the tree diagram, I'm going to copy this and I'm going to bring it down to the questions because the questions are coming up and you guys need to help me. I'll bring my tree diagram down. You can look at yours if you want, but here are the questions. I'm going to put my tree diagram next to the questions here so we can see it. And I'm going to shrink it a little bit because it's a bit big. All right. Let's shrink it some more. So we have a diagram right next to us to work with. Okay, so there's a diagram here, the questions. All right, who would like to try the first one? Raise your mighty hand. Anybody?
Somebody.
Anybody?
Somebody.
Somebody.
Anybody. And Tabileng wants you to repeat how you got your tree diagram. So I'm not sure if she wants an explanation of the whole thing or how you got the letters.
Okay, no problem. No problem. It's quick enough that we can do these branches again. Bianca, thanks for that hand. We're going to come to you now. I just want to quickly redo this diagram. Thanks, Bianca. We see that hand. All right, so let me erase the second and the third child, and then we'll start from the first one. All right, you have to agree that the first part of the tree diagram is pretty easy. When you have your first child, if you're a family and you have your first child, you have 2 options. It could be a boy or a girl. So we have 2 branches here. Okay, now let's pretend you have a boy for the first child. So you've got your boy and you have your second child now. Your second child could be a boy or a girl. So for the boy branch here, which is this top one here on yellow, I'm going to draw on there another option. So we could have we got a boy for our first child, but once we have the second one, again, we have an option of a boy or a girl. Or you could have had a girl first. Come down to the bottom branch, the girl, the G. When you have your girl first and you have your second child, the option again as your second child is to have a boy or a girl. So far, this is a two-child family. Only 2 kids. Okay, and if you look at this now, there are 4 possibilities. You could have a boy first and then a girl. Or you could have a boy first and then a boy, 2 boys. Or you could have a girl first and then a boy. Or you could have a girl first and then another girl. So those are all the possibilities if you have 2 kids. But let's go back to the top one, boy and then boy. If you have 2 boys in your family and you have a third child, again, there are 2 possibilities once you've had 2 boys, a boy or a girl. So this is the third child now, the third part of our tree. Okay. Or if we go down one more to this branch, when you have a boy first and a girl second, you've got 2 kids, a boy, girl, and a boy first and a girl second. You could have another child, which could be a boy or a girl. Okay. So we fill the diagram out like that. For each of these now, in the second child, which is B or G, we've got to do another boy or girl branch on each one. So this is the third child now. These are all the possibilities, combinations of boys or girls if you have 3 kids. Okay, so we drew that diagram. Here it is on the right-hand side. And then instead of just looking at the branches, I wrote in brackets here all the possibilities using the letters. So for the first branch here, which is boy, and then another boy, and then another boy, we wrote there BBB, boy, boy, boy. Okay, so I'm just writing in brackets letters, excuse me, for all the possibilities. Okay, whoops. Now we can answer any question on this scenario because we've got a tree diagram. It's easy. So, Bianca.
It is your time to shine.
Bianca.
Hi, sir.
How are you?
My tree diagram, is it wrong if I started with writing girl, 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 and boy?
No. If you've started with girl first and you completed it, you will have the exactly same combinations that I do, but just in a different order. You should still have 8 combinations. And if you look at all of my brackets and look at all of yours, we will have the same thing, but my boys will be at the bottom. Sorry, on yours, the boys will be at the bottom and the girls will be at the top. So the letters will be looking a little bit different, but we should have the exact same letters. We should have covered all 8. We should have all 8 possibilities, and we should get the same answers when we answer these questions. You let me know if we don't, but we should. All right.
Okay.
Thank you. Awesome. All right, here come the questions. Bianca, where you are, don't go away. Bianca, help us with the first question.
Many.
Yes.
8 children.
8. How many possible combinations of children are there? There's not 8 children, but there's 8 possible combinations. You're right. All right. Yeah. Very good. There are 8 possible combinations when you have 3 kids. Very good. Your number is right. Thank you, Bianca.
Okay.
All right. Who would like to answer question 2? Emmanuel, you're there. Should we try and see if your microphone is working? Emmanuel, you there? Let's try.
Yes, sir.
Excellent. All right. Question 2 says, determine the probability that a couple will have 3 boys. Show your answer as a fraction.
Pause. Okay. Determine the probability that the couple will have 3 boys. So there is only one, like from what we've seen. So it's going to be 1/8. So because out of the 8 outcomes, only once did we get 3 boys.
Very good.
It's going to be 1/8. Should we give it as a percentage or?
Do exactly what the question says. Do exactly what the question says. If they say fraction, you give a fraction.
There we go. Yeah, you can't simplify it. It's a fraction.
That's done. Excellent. Thank you, young man. Good job. Thank you. All right. So we saw out of all the possibility, there's only once that we had 3 boys. Okay, we can see that on the right-hand side, I circled it for you. So that's 1. And we know the total is 8, so it's 1/8. All right. You see how easy it is to do the questions now that we have a tree diagram? Who's going to help me with the next one? Question 3. I know you guys have seen it.
And there's actually a few answers on the chat.
Oh, yeah, you see, these guys always got fast fingers. Always fast fingers. These, oh my gosh. Okay. Let's question 3. All right. Don't do the question 4. Just wait for me, guys. Yo, determine the probability that the couple will have a girl first. Show your answer as a decimal. All right. So girl first, I see that here, 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 and here. 4 times out of the possible 8. So if I'm going to write here girl first, G first, equals, we're going to do the fraction first always. All right, so it's 4 out of 8. And if you show that as a decimal, you guys shouldn't need a calculator for that. 4 over 8 is the same as 1/2. It's a half. So that should be 0,5. Okay. All right. So it should be 0,5 as a decimal. Okay, as a decimal. There we go. All right. Who's going to help me with question 4? Who's going to help me with question 4? Anybody?
Somebody.
Somebody?
Anybody.
Anybody? Question 4. You brave souls. You brave souls. Come on, who's brave tonight? I know it's cold. I've had flu. My voice is a bit croaky. Don't worry about that. Anybody out there wants to help us with question 4? You guys are going to make me do it myself. Oh. Sakile, come on now. Where's Sakile? I can always rely on Sakile. Sakile, you there? Oh, even Sakile is quiet. All right, guys, what do you think for question 4? Let's have a look. Determine the probability that the couple will have 2 girls and a boy in any order. Show your answer as a percentage. 2 boys and a girl in any order. All right, let's check. So we look at our diagram. I just want to delete all the markings that I've already put there. Where do we see 2 girls and 1 boy in any order? So you want 2 G's, 1 B in any order. There we go. There's 2 G's and 1 B. I'm going down. There's 2 G's and 1 B. Any order. Here's 2 G's and 1 B. Any order now. So how many times did it happen? 3 times. All right. So the probability of getting 2 girls, 1 boy in any order is equal to 3 out of 8. And to show that as a percentage, I times by 100. As easy as that. Get the calculator. 3 over 8 and times by 100. 37,5. 37,5. I like showing the second decimal. It's not a big issue if you don't. I just like showing the second decimal. There we go. Good job. All right. Brave souls for question 5. Any takers? I'm just going to delete the markings that we have on the diagram. And I'm going to bring it down so we can use it to help us with question 5. This diagram is very useful to answer these questions. I'm going to bring it down. Let's bear with me while I bring down the diagram. Here's question 5. Okay. I'm going to put a chat now. Right, there's a diagram. Here's question 5. Let's read it all together. Determine the probability that the couple will have a boy, then another boy, and finally a girl. Show your answer as a fraction and a percentage. Who'd like to try this one? Anybody? Sakile.
Hi,
Sakile,
sir.
how are you doing?
I'm doing good.
Good. How do we do this? First of all, before you tell me, what do they mean when they say that the couple will have a boy, then another boy, and finally a girl? So that sentence there, what is that?
Yes.
What are they trying to
Um,
say?
like, should we look for a bracket where they have like 2 boys and 1 girl?
In any order? Or are they
Any
specifically
order.
saying, I think you must be careful. They say, have a boy, then another boy. So this keyword here,
Oh, it's not in any order. Yeah,
yeah,
it's not in any order.
the keyword there
Okay.
is then. And then the keywords here, and finally. All right. So this means that there's a sequence. This means it has to be in an order.
Okay.
All right. So
Um,
where do you see it?
the second bracket.
Second bracket.
Yeah.
Boy, then girl. There it is.
Yes. 1
Excellent.
over
So what?
8.
1 over 8 and times by 100, or what did you get?
Okay, let me just quickly calculate.
Go for it.
12.5%.
Excellent. There we go. 1 over 8 times 100, 12.5%. Thank you. Sakile, well done. Thank you very much.
So, bye.
Bye. All right. So this question was specific with the order. How did we know? There were words in there. So math literacy is not just about the math. It's about interpreting the question. So they say determine the probability that a couple will have a boy, then another boy. So you have a boy first, then a boy, and finally a girl at the end. All right. So the words and finally means the girl comes last. So it's boy, boy, girl. That's a specific order. All right. We only saw it here in the second bracket. Boy, boy, then girl. Okay. That's the only time we only saw it once. 1 over 8 times 100 is 12.5%. Okay. Yes, Kaslecho, 12.5% as a decimal, 0.125. Excellent. Always practicing the decimals. All right. Now, I hope you guys understand how to do tree diagrams. Yes, drawing the tree diagram from the start can be tricky. All right. The key is here to think yourself the first time. Once you get the first branches, it'll be easy from there. The first time. So if we look at our diagram here, the first time it happens, how many possibilities are there? The first time it happens, how many possibilities are there? For example, if they ask you to draw a tree diagram where you throw a dice, in chat, type it out there. How many possibilities when you throw a dice? How many possibilities when you throw a dice? In chat, everybody, how many possibilities when you throw a dice? How many numbers could you see? 6, exactly. So if they ask you to draw a tree diagram where you throw a dice, you will have to draw 6 branches. You pray that I give you that one because this tree diagram will get messy. But yes, you throw that dice, there are 6 possibilities. What if they say throw a dice and then toss a coin? Well, the options are 1, 2, 3, 4, 5, 6 on the dice. Then for the first one, you toss a coin. You can get 2 possibilities, either heads or tails. You could throw the dice and get a 2 and then toss the coin and get heads or tails. Throw the dice, get a 3, then toss the coin and get heads or tails. Okay, so you take each branch from there and you carry on. All right, it's the first step that is usually the most difficult one. Okay. Sometimes they ask you to draw it. Often they'll ask you to complete it. And you must make sure that you have these, oopsie, go down. You have the bracketed solutions here all written down. Because that's what's going to help you get your answer when they start asking you the questions. All right. Now, that's a tree diagram. There is another way to represent this, a two-way table. I'm going to quickly show you and then we'll see how many questions we can get. All right, so here we go. Here's the scenario. Read it up there on the left. An experiment is planned where 2 dice are thrown, and the numbers shown on the dice are recorded. There is a blue one and a red one. Okay, so there is a red dice here at the top. That's the red dice, and then blue is here on the left. Okay, so draw a two-way table to show the possible outcome. So on the left-hand side of the two-way table, these are all the possibilities when we throw the blue dice. You can get a 1, a 2, a 3, a 4, a 5, or a 6. In the rows, when you throw the red dice, you can get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, yes, easy marks. So these are all the results. For example, I'm going to go along the first row here. Okay, I'm going to start there. You could get a 1 on the blue dice and a 1 on the red dice. 1 and a 1. This is how you show the results. 1 and 1. Now, sometimes you don't even need the letters. Just 1 and 1 is sufficient. Okay. But they've got letters here to help you. So you get 1 on the blue and 1 on the red. All right. What's the possibility when you throw a 3 on the blue and a 4 on the red? Well, here's 3 on the blue. Here's 4 on the red. So if we go across and down, that's what it'll look like. 3 and 4. Okay, so this table can show us every single possibility. All right, here's the question in chat. You can put it there. How many possible combinations of pairs of numbers are there? How many possible combinations are there? Looking at this diagram, there are all the possible combinations. How many possible are there? To work out, you can say 6 for the one, 6 for the other. 6 times 6 is 36. Yes, the answers are coming through there. All right. So if you counted all these blocks here, all the possible outcomes, there'll be 36 possible outcomes. All right. There's the question. What is the chance of rolling a 3 on the blue and any number on the red? 3 on the blue and any number on the red. So what we'll do is we'll go down to our diagram, excuse me, and we'll look for 3 on the blue, which is here. And we go all the way across. You can see for every single one of these, there's a 3 in the blue, 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 and any number on the red. How many are there? There are 6. All right. I'm not going to write what's in the bracket. I'm just going to say probability is 6 out of the total, which is 36. And then if you want to change to a percentage or decimal, you know how to do that. Let's see the next question. Determine the probability that a double 6 will be thrown. Double 6 will be thrown. Where is that? There's only one place you can get a double 6. That's right there at the bottom. Okay, how to find it? A 6 on the one and a 6 on the other will get you a double 6. It only happens once. So a probability of getting 6 and 6 only once out of 36. And remember, when we were talking about dice the last lesson, everyone was saying, sir, you never get a double 6. This is why, because it's only once out of a possible 36. What is that as a percentage? Let's have a look. Go to my fraction, change the bottom to 36. 1 out of 36. What is that a percent? You've got a 2.78% chance of throwing a double 6. This is why getting a double 6 is so hard, because it's only 1 out of 36. 2.78% chance. That's nothing. Well done, Eminati. Well done. It's nothing. It's tiny. Out of 100%, that is teeny tiny. This is why it's so hard to get a double 6. Okay, last question, and we're going to call it a night. Any brave soul is welcome to answer this one. Question 4, determine the probability that you will see A 2 on the blue and a 5 on the red. 2 on the blue and 5 on the red. Look at the diagram. Let's go across. 2 on the blue. Where do we see 5 on the red? Ah, there it is. 2 on the blue, 5 on the red. What is that probability? Again, yes, you guys saw it. All right, so 2 blue and 5 on the red. .78% again. Okay, please don't worry about what you write in these brackets. You're not going to get penalized if you don't write that. What they're looking for is to see what's in your denominator and what's in your numerator. That's what they want to see. If you can show that, you show that you understand this experiment, the scenario. Okay, are there any questions? Any questions? Anyone want me to go over anything again? Or are we all good 100%? Like Kia says, speak now, don't hold your peace. Speak now. Speak now. The notes. So Kia, which you mean the scenario at the top? Is that what you're talking about, Sakile? You guys can take a picture of this, take a screenshot. I'll erase, or in fact, I'll leave them in there if you want. Show us the notes, the last one. All right. Or the last question, the notes.
I
Kia,
think they're referring to the tree diagram.
oh, the tree diagram? All right. Okay, let's go up to the tree diagram. There's the tree diagram. I'm going to put you a third child. All right. Like the explanations on how to do it. Oh, you want notes? Okay. Here's some notes for you. Number one, ask yourself, for the first branch, how many possibilities are there? Each possibility is a branch. All right. And then a big star. Do it in pencil because I promise you, you're going to rub it out a couple of times. Okay. Do it in pencil. The spacing is going to be an issue. Do it in pencil, please. All right. The best thing to do for those guys asking on notes on how to draw it is to check the video when it comes out in a couple of days' time and go back and watch when I drew this because I explained it very carefully when I drew the diagram. So go back and check the video, go to that section where I started drawing it, and then follow from there. Okay, but these basic instructions should help you start it off. Once you get it started, it's quite easy to finish. Okay.